Hi guys, let's look at the next question. But before we start this video, let's quickly revise the four properties of chords that we learned in our previous video. Property 1 said line from center which bisects chord makes angle of 90 degree. Then we did the converse of this, which means if a line makes an angle of 90 degree with a chord, which is starting from the center, then it bisects the chord. Next, the second one that we talked about was equal chords are equidistant. Right? Equal chords are equidistant from the center. And then we did the converse of this, which meant that if two chords are equidistant from the center, then they must be equal. Good. Now that we've revised these four properties, let's go ahead and solve some more questions. So question number 4. A chord of length 24 centimeter is at a distance of 5 centimeter from the center of a circle. Let's just draw a rough diagram. Okay, so a chord of length 24 centimeter is at a distance of 5 centimeter from the center of a circle. So let me draw a chord of length 24 centimeter. This is chord AB. This length is 24 centimeter. This is the center of the circle O, and the distance between the chord and the center is 5 centimeter. And the distance basically means this is perpendicular. So yes, find the length of a chord of the same circle which is at a distance of 12 centimeter from the center. So there's another chord which is 12 centimeter. Let's call this chord C and D, and the distance between these two is, let's say, need to show the second one. The distance between them is 12 centimeter. Yes. Oh, my 5 centimeter looks bigger than 12 centimeter, but doesn't matter, we'll ignore it. What we need to figure out is find the length of the chord. So we need to figure out the length of CD. So if I remember correctly, a line which is perpendicular from the center of a circle to a chord bisects the chord, which means let's call this point X and let's call this point Y, which means AX will be equal to BX because OX is perpendicular to AB. So let's start writing. AX is equal to BX since OX is perpendicular to AB, which means perpendicular from center of a circle to a chord bisects it. That's the reason. Which means AX is equal to BX is equal to AB upon 2, which is equal to 12 centimeter. So AX is 12 centimeter. Now let's apply Pythagoras theorem in the triangle OAX. That will help us get the radius. So in triangle OAX, using Pythagoras theorem, what I get is OA square is equal to 5 square plus 12 square. Therefore OA would be equal to 25 plus 144, the square root of it, which means 25 plus 144, that's 169, the square root of which is 13. So 13 centimeter. This is where I would request you to remember your Pythagorean triplets. 5, 12, 13 is a simple Pythagorean triplet. So in this case, the radius is 13 centimeter. Now let's join C and O. So OC is a, yes, OC is the radius. OC is equal to radius, and this is given equal to 13 centimeter. We calculated this in point number 3. So OC is 13, OY is 12. Now again apply Pythagoras theorem and calculate CY, which means in right triangle OCY using Pythagoras theorem, what I get is 13 square is equal to 12 square plus cy square, which means cy would be equal to 13 square, that's 169, minus 12 square, that's 144. Therefore cy is equal to 5 centimeter. Now what do we need to calculate? We need to calculate the length of the chord. So we've just calculated half of it, which means yd is also equal to cy. So the total length will be 10. We still need to write that. Since OY is perpendicular to CD, therefore cy is equal to yd is equal to 5 centimeter. Therefore length of chord is equal to 10 centimeter. Done. Let's look at the next question. The next question that we do is question number 5. Let me just open that question. Question number 5. It says AD is a straight line, OP is perpendicular to AD. So OP is perpendicular to AD, which means it is dividing the chord BC into 2 equal halves and dividing the chord AD into 2 equal halves. So this is a set of concentric circles. O is the center of both the circles. OA is equal to 34. Let's start writing. Since OP is perpendicular to BC and OP is also perpendicular to AD, which means therefore BP is equal to CP and AP is equal to DP. The reason is perpendicular from center of a circle bisects the chord. So in this case, for the bigger circle, AD is the chord, it's bisecting AD. For the smaller circle, BC is the chord, so it's bisecting BC. Perfect, which means AP and PD are equal and BP and PC are equal. OA is given equal to 34, which means the radius of the bigger circle is 34. OB is 20, which means the radius of smaller circle is 20, and OP is 16. So let's apply Pythagoras theorem again. So in a right triangle OBP, using Pythagoras theorem, I get OB square, which is 20 square is equal to 16 square plus BP square. This is 400 minus 16 into 16, that's 256 is equal to BP square. Therefore BP would be equal to square root of 144, that's 12 centimeter. So this is again a Pythagorean triplet of 12, 16 and 20. So 12, 16 and 20, which is nothing but 3, 4, 5. 3 multiplied by 4, 4 multiplied by 4 and 5 multiplied by 4. So this is basically a 3, 4, 5 Pythagorean triplet. Good, so I've got the value of BP. I need to find the value of AP. So if I can subtract them, I'll get the value of AB. So now in a right triangle OAP using Pythagoras theorem, what I get is 34 square is equal to 16 square plus AP square. Now 34 square is 34 into 34, which is equal to 1156. Yes, I remember that. And 16 square, that's again 256, is equal to AP square, which means 1156 minus 256, that's 900. Therefore AP is equal to 30 centimeter. So I've got the value of AP and I've got the value of BP. I should be able to calculate AB. So this is since AB is equal to AP minus BP, which means 30 minus 12. Therefore AB is equal to 18 centimeter. Done. Again, repetition of the same concept again and again. That's what we are doing right now. Let's look at the next question. The next question that we do is question number 6. In a circle of radius 17 centimeter, 2 parallel chords of length this and this are drawn. So let me just draw let me draw a circle which will have two parallel chords. Okay, and in the first case the chords are on the opposite side. So let me draw the first case. So this is chord 1, this is chord 2, this is the center of the circle. Radius of the circle is 17 centimeter, which means this is 17, this is also 17, 17 and 17. Next, these are parallel as well, which means this is parallel to this, 30 and 16. So let this be of 30 centimeter, this is 16 centimeter. Find the distance between the chords, which means I will have to find the distance. Let's draw the perpendicular, which is basically the distance. Similarly, extend the line here. This is the distance here. Distance between a point and a line is the perpendicular between them. So let's call this chord AB. Let's call this chord CD. Let the circle center be O. Let this be point P and let this be point Q. Done. What we need to find is the distance between the chord, which means I need to find PQ. So if I divide this into two different triangles, then if I find OP first and OQ next, I should be able to figure out the length of OP plus OQ, which will be PQ. Now let's start writing. Since OP is perpendicular to AB and OQ is perpendicular to CD, therefore OP bisects AB and OQ bisects CD. Reason: perpendicular from center bisects the chord. Now what this means is AP is equal to BP is equal to 15 centimeter and CQ is equal to QD is equal to 16 by 2, that's 8 centimeter. So this is 15 and this is 8. Now in a right triangle OPA, using Pythagoras theorem, what I will get is 17 square is equal to 15 square plus OP square, which means OP would be equal to 289 minus 225, that's 64, which means 8 centimeter. In case you remember, 8, 15 and 17 is also a Pythagorean triplet. Good, so we've got the value of OP. Now let's find the value of OQ. So in a right triangle OCQ, using Pythagoras theorem, what I get is 17 square is equal to 8 square plus OQ square, wherefore OQ is equal to 289 minus 64, the square root, which is square root of 225, which means 15 centimeter. Therefore PQ is equal to OP plus OQ is equal to 8 plus 15, that's 23 centimeter. Therefore distance is 23 centimeter. That's what they wanted. This is done. So this is 23 centimeter. Now the same question has a second part, which is if both these are on the same side. I'll just draw a rough diagram and then I think we will be able to solve this without any problem. So in this case, this is the bigger chord, this is the smaller chord. Obviously the chord which is closer to the center of the circle will be the longer chord. So in this case, the straight line is like this and my two circles will look something like this. One here, one here. So let's see which was the bigger chord. AB was the bigger chord and CD was the smaller chord. So and this we had calculated, we kept the point as P and we kept the point as Q. This radius still remains 17 and 17. So this OP we will calculate as 8 and OQ we calculated as 23. So in case 2, the distance will be the difference between them. So in this case, the distance will be 15 minus 8, which is 7 centimeter. Very interesting question, as long as you are able to visualize it. Let's look at the next question. The next question that we do is question number 7. It says two parallel chords are drawn in a circle of diameter 30 centimeter. So if this is 30 centimeter is the diameter, then the radius is, yes, 15 centimeters. So let me just draw a rough diagram. So this is my circle. Two parallel chords are drawn. Let me mark the center. Two parallel chords are drawn. Length of one chord is 24. Okay, so this is length 24. Next, distance between the two chords is 21 centimeter. Okay, so can the chords be on the same side of the circle? No, they cannot be, because the radius is 15, which means the maximum length on one side available is 15. So, and since the distance between these chords is 21, which means they are on the opposite sides of the center. Right. So this is our chord AB, which is our chord 1. This is chord 2. Let's call it CD. Length of one chord 24 centimeter. Distance between them is 21 centimeter. This chord and this chord are parallel. Let's just mark the distance between them, which is passing through the center, because line from the center of the circle to a chord is 90 degree to it, and bisects it as well. So in this case, let's call it point P, and let's call this point Q. Let's again apply Pythagoras theorem and see what we get. What in this case is given is PQ is 21 centimeter. So let's start writing. Let OP is equal to X centimeter. Therefore, OQ is equal to 21 minus X centimeter, because the distance, total distance is 21 centimeter. Next, since OP is perpendicular to CD and OQ is perpendicular to AB, therefore AQ is equal to BQ is equal to 12 centimeter and CP is equal to PD. Distance we don't know, because length of CD not given. Let me just make the radius as well. These two radius, let's join OA and OC. The diameter is 30, which means the radius OA is 15 and OC is also 15. This is X, and we got OQ as 21 minus X. This we got as 12. This we got as 12. We don't know the value of CP and PD. So let's apply Pythagoras theorem in a right triangle OAQ using Pythagoras theorem. What I get is 15 square is equal to 12 square plus 21 minus X square. Maybe I should change it, because then my life will become much simpler if I take this as X and the other one as 21 minus X, because it's easier to calculate with single term than with two term. So let me just rewrite my assumptions. So let OP is equal to OQ is equal to X and OP is equal to 21 minus X. I could have done 21 minus X here as well. I would have still got the value of X. That's just complicating life. This is X square. So this would be, therefore X would be equal to 15 square. That's 225 minus 12 square. That's 144. The square root of which, in this case, this is equal to 81. This is 9 centimeter. This again is a Pythagorean triplet, 9, 12 and 15. It is nothing but 3, 4, 5 Pythagorean triplet. Okay, so then I have got the value of X as 9 centimeter, which means OQ is 9, which means OP is 21 minus 9, that's 12 centimeter. Done. Now we will apply Pythagoras theorem in this right triangle OPC using Pythagoras theorem. What I get is point number 5, which says 15 square is equal to 12 square plus Cp square, which means Cp would be equal to 225 minus 144, square root of which is square root 81, which is 9 centimeter. So Cp is equal to 9 centimeter, Pd is equal to 9 centimeter, which means therefore Cd is equal to Cp plus Pd is equal to 9 plus 9 centimeter. Therefore Cd is equal to 18 centimeter. Therefore length of the other chord is 18 centimeter. That's what they wanted. Again, I hope you've realized that we've been using the same property again and again, including Pythagoras Theorem. That brings me to the last question that I'll solve with you in this exercise. That's question number 9. Question number 9 says, circle with diameter O in which AB bisects the chord CD at point E, in which AB bisects, so not cuts, bisects. My mistake, I should have written this as bisects chord D at E, which means CE and DE are equal and they are 8 centimeter each. EB is equal to 4 centimeter. What we need to figure out is radius of the circle. So let me just mark the radius of the circle. Let's just join OC, and I need to figure out the radius. So let's again see what is given. So since OE bisects CD, therefore OE is perpendicular to CD. The reason for this, line from center bisecting a chord is perpendicular to the chord. So that's the reason, which means now I have a right angle triangle. So which means in a right triangle OEC, I can mark this as 90 degree. What I get is, using Pythagoras theorem, I get OC square, which is my radius, is equal to CE square, which is 8 square, plus what is OE? I don't know OE yet. OE square. So let OC is equal to R, which will also be equal to OB, which means OE will be equal to OB minus EB. OE is equal to the big length OB minus EB, which means OB we've taken as R and EB we've taken as 4. So OE is equal to R minus 4 centimeter, which means let's put this in the formula. OC square is equal to 8 square plus R minus 4 square. OC is R, we've taken it to be R, so R square is equal to 64 plus R minus 4 whole square in the form of X minus Y whole square, which means X square plus Y square minus 2XY, in this case 8R. R square and R square gets cancelled, which means 8R is equal to 64 plus 16, that's 70, and 80, 80, which means R is equal to 10 centimeter. So the radius is 10 centimeter. That's what we needed to calculate. That finishes this exercise for me. But before I leave, let me give you some homework questions. Homework questions for you would be question 2, question 3, question 8, and question 10. Thank you so much. Take care. Be safe. Bye-bye.